What if the car you buy today is still running on the very same battery? 30 years, 50 years, or even longer? BYD has just unveiled two battery technologies that could make the concept of battery degradation obsolete. One achieves 10,000 charge cycles. The other reaches 400 to 500 watt-hours per kilogram, powerful enough to push EVs to supercar levels as early as 2027. This isn't just an upgrade, it is a generational leap. Start with the solid-state breakthrough. BYD has chosen sulfide electrolytes, a chemistry known for very high ionic conductivity. In simple terms, ions can move through the material more easily than in many other solid electrolytes. That matters because it directly influences two of the biggest EV pain points: charging speed and cold weather performance. Faster ion transport supports higher charging power and better output in low temperatures, areas where traditional lithium iron phosphate cells can struggle. BYD is targeting energy densities of around 400 watt-hours per kilogram for the first generation and up to 500 watt-hours per kilogram for the second. To understand how significant that is, consider that many current LFP packs operate around 160 to 180 watt-hours per kilogram at the cell level. If you more than double that figure, you fundamentally change what an EV can do. A vehicle currently equipped with a 60 kilowatt-hour LFP pack, delivering roughly 400 to 450 kilometers of range, could theoretically approach 1,000 kilometers if the same weight were replaced with a 400 watt-hours per kilogram solid-state pack. Even if real-world integration reduces the headline number, the jump remains transformative. The first applications are unlikely to appear in affordable family sedans. BYD is expected to deploy these early solid-state packs in its highest-end vehicles, potentially including ultra-performance models. That strategy makes sense. Early production volumes will be limited, and costs will initially be higher than LFP. Premium vehicles can absorb that cost while showcasing the performance benefits: lighter weight, longer range, and dramatically faster charging. Small-scale pilot production is scheduled to begin around 2027. With broader commercialization targeted closer to 2030. Cost parity is the critical milestone. BYD executives have indicated that by the end of the decade, solid-state batteries could approach the cost of today's liquid electrolyte lithium-ion cells. At present, solid-state packs are expected to be roughly 25 to 30% more expensive than LFP. But once scale improves and manufacturing stabilizes, that gap could narrow significantly. If by 2035 an EV with a 1,000-kilometer range and ultra-fast charging costs the same as a comparable internal combustion vehicle, the economic argument for gasoline weakens dramatically. Add in fewer moving parts, lower maintenance, and quiet operation, and the shift becomes structural rather than incremental. While solid-state targets the high-performance frontier, BYD's sodium-ion program may prove even more disruptive for the mass market. The company's third-generation sodium platform reportedly addresses earlier challenges such as sodium precipitation and thermal stability. The result is a projected cycle life of around 10,000 full charge-discharge cycles. For context, many current LFP batteries are rated for 3,000 to 5,000 cycles under typical conditions. What does 10,000 cycles mean in practical terms? If a driver performed a full equivalent cycle every single day, it would take over 27 years to reach 10,000 cycles. In reality, most drivers charge between 20% and 80% and do not fully cycle the battery daily. Under more typical usage patterns, the functional life could extend several decades. At that point, the battery is no longer just a component of the car. It becomes a long-term energy asset that could outlast the vehicle itself. Such durability opens new economic models. A battery removed from an aging vehicle could be repurposed for home storage or even small commercial applications. Instead of degrading into obsolescence after 8 to 10 years, it could continue operating for decades in second-life scenarios. That dramatically improves total life cycle value and reduces waste. Energy density for sodium-ion cells has not been fully detailed by BYD. But comparable sodium technologies from other major manufacturers have reached around 160 to 180 watt-hours per kilogram. That places them near first-generation LFP performance. While sodium will not match solid-state for long-range luxury vehicles, It does not need to. Its core advantage lies in cost and material availability. Sodium is abundant and widely distributed, reducing exposure to lithium supply volatility. The cost projections are where sodium-ion becomes truly disruptive. Industry forecasts suggest that advanced sodium packs could fall to around $20 per kilowatt-hour within several years, compared to roughly $60 per kilowatt-hour for current LFP cells. If that target is achieved, a 60 kilowatt-hour battery pack could cost little more than $1,200. At that level, the battery ceases to be the dominant cost driver of an EV. A $15,000 electric car with a multi-decade battery life becomes realistic rather than speculative. For comparison, internal combustion engines involve complex transmissions, exhaust systems, fuel injection components, and extensive mechanical maintenance. If EV battery costs plunge while durability increases, the total ownership equation shifts decisively. The traditional argument that EVs are more expensive upfront erodes. By the mid-2030s, it is plausible that electric vehicles offering long-range and ultra-fast charging will cost the same as or less than gasoline counterparts. BYD's dual strategy also positions it as a supplier, not just a vehicle manufacturer. As legacy automakers hesitate or delay aggressive electrification plans, battery leadership becomes a competitive weapon. If BYD can deliver solid-state packs for premium segments and sodium-ion packs for entry-level vehicles at unmatched cost, it can supply both its own brands and external partners. That expands influence far beyond its domestic market. The broader implication is acceleration. Solid-state addresses performance anxiety, range, charging time, cold weather output. Sodium-ion addresses affordability and longevity. Together, they remove many of the remaining objections to EV adoption. Want 1,000 kilometers of range and rapid charging. Solid-state aims to provide it. Want a low-cost vehicle that lasts for decades with minimal degradation. Sodium-ion is designed for that role.